Sure, thanks, Adam. We were engaged as designing and our design team, I believe, mid-year, so July 2018, and we worked through with council and a series of workshops and community engagement to develop their new recreation centre, which is now the Rolanda Recreation and Convention Centre, comprising of some 6 dry courts. So we've got basketball in there and some community spaces, as well as some function spaces. And then it's on the current site of their existing outdoor 50-metre pool. And the centre encapsulates that and also includes indoor aquatic zone with 4 aquatic pools, a 25-metre pool, leisure pool, some warm water pools, and to swim, obviously. So we were early on identified that to represent the region, there's a big timber industry there, and that's part of the history of the region, and a large industry, that we wanted to reflect that in the design. So we were investigating different ways to get timber into the project and assessed it from various points of view to get the economics right and what can be efficient and the best way to showcase the use of timber.
Mm. And what is the structure being used for the project? Just off air, we were speaking a little bit about it, and it's timber's part of it, but you're also using a combination of materials as well, right?
Yeah, absolutely. So through our investigations, it wasn't viable to build the entire place out of timber. We've got some very large spans and the properties in different zones. We've got dry zones and wet zones. So there was properties that timber brought which were beneficial in some areas, and it was cost prohibitive in other areas. So we've got a complex hybrid of structure where we've got our main core that hosts all the sort of wet areas and amenities and kitchens and pipes, and that's a concrete structure down the center of the building. And then off of that, we've got a hybrid timber and steel structure over the playing courts. And then the timber zone, which is for the aquatics, is all timber.
Mm. And so why was timber selected for the aquatic regions within the precinct or the aquatic centre?
So in our feasibility study, which was early on in the design phase, we were testing different ways to get timber in and the different uses and benefits that the actual inherent properties of timber brought to the project. We looked at it again in the dry areas, and the economics and things weren't quite right there. So we've integrated some timber columns in what is holistically a steel structure there. But in the aquatic zone, we found the properties of the timber, and we did a whole of life costing there. And so the way that the steel corrodes and the maintenance and the ongoing maintenance of steel to get these large spans over the pool, we looked at the timber, and then we started investigating the different types of timber that we could use and the different structures that we could come up with. And the real benefits we got was it's actually quite a stable environment in a pool. Once all the mechanical systems and everything are operating, the temperature is, while it's humid, it's still quite controlled, and it's quite controlled throughout the day and throughout the year, because we need to maintain that to keep the pool temperatures right. So the timber allows us, it eliminates the heat and cooling and the thermal expansion of the timber, because the environment's quite stable itself. And then the other benefit we looked at over steel was the recoating times and the application and the maintenance on the timber. So the timber's oiled, and it's the right grade of timber, so that once it gets its stable moisture content, it's actually quite stable and it doesn't get impacted by any further moisture. Whereas with steel, there's a lot of typically trusses, you've got a lot of welds, you've also got all the coating to protect it from what is a corrosive environment. And the ongoing maintenance of that is where the timber starts becoming economical, because to strip down above a pool, you're working at heights, you've got to close the whole centre down, you have to sand back corrosion on a steel structure, you've got to recoat. Whereas the timber, because it's an oil treatment, you just need to reapply the oiling. And so it's the frequency that has to occur and the time that the pools are closed actually come into factoring in why the timber is beneficial there. The other part was the acoustics and the warmth it gives. Typically, to be this corrosive resistant environment, our building materials are typically hard surfaces. So that works against acoustics, and with all the water splashing and water play equipment in there, pool halls are normally quite loud. And we then start having to add a lot of acoustic treatment into it, which is more fixings and more mechanical fixings, which we want to try and avoid. The timber gave us the rafters that we ended up with in the design. The geometry themselves actually break up the large roof plane. So it starts reflecting the sound differently and starts absorbing the sound. And the property of the timber itself has some absorption too. So when we're doing our acoustic analysis with the acoustic engineers, we started talking them through all the different timber options, and they were getting very excited because it made the space perform better without having to start adding more. We do have more in there, but it limited how much additional acoustic treatment had to be put in there to make the space comfortable.
Absolutely. They were it's such interesting answers, because I assumed a big part I'd imagine would be aesthetics, but there's also these pragmatic reasons behind that, and aesthetics seems like it's just a bit of a bonus, cherry on the cake. So,
don't get me wrong, that was probably from when we first looked at it, the bit that captured us the most, but then we started investigating these technical requirements and properties, and the fact that we can get materials that address multiple issues and multiple items, and we start integrating this bigger holistic system, is actually quite exciting, and we're really looking forward to seeing how the space performs. But the aesthetics still quite important, and the timber actually brings some warmth to the space as well, which, similar to the conversation with the acoustics, where we've got a lot of hard surfaces, and in the pool hall, they can feel quite cold. So the idea, we've got a lot of glazing to get a lot of light in, and this timber will add some warmth to the space as well.
Mm. You've touched on moisture a little bit, and there's some parts within the building where you're avoiding moisture, where it's unexpected, but then you've obviously got timber in an aquatic zone with pool and moisture everywhere. So what is the durability considerations you've got for the timber?
So the engineering team did a lot of investigation with both local and international timber suppliers, and a lot of precedent studies to work out the right grade and the right properties of the right type of timber to be used to make it suitable. And once Hess was engaged on the project, our workshops with them, obviously they've got experience building timber structures in pools overseas as well. So once we started refining down and working with the contractor and with Hess, there's different grades that Hess can provide that other people can't. And so we started focusing and drilling down on the properties of the timber specific with Hess.
And Ty, so with the big Glulam beams, we'll speak about logistics in a bit, because that's one of the most interesting parts of this project. Getting your Glulam beams that are going to be on show aesthetically and through transport, do you have different visual grades of Glulam that you supply, and if so, what are the differences between your different Glulam products?
Yeah, thanks, Adam. Hey, everyone. So I mean, there is various levels of visual grades that we can offer, as well as structural grades. So it starts as a non-visual, which is more knotty and more natural defects in timber, and then as you progressively get more expensive and refine it into a better appearance grade. But we've got non-visual, and then it goes industrial, visual, and visual grade. Visual grade being the highest, and which is what we're supplying here, is it's a more consistent appearance in color tone and size and quantity of knots and everything. So but it sort of doesn't change the way that we manufacture the panels. They're all manufactured the same way, same glues and everything. So maybe just touching back on the durability side of things, I suppose with the aquatic centers, is that what Ben was saying exactly right. It is actually quite a controlled environment in terms of humidity levels and temperature. Yes, it is moist. It's a moist environment, but it's not exceeding the level where the timber then exceeds a moisture content that can lead to molding and things like that, moisture content of the timber, as long as that doesn't exceed around 18% for a prolonged period of time, it won't start to deteriorate, which in aquatic environments doesn't occur. Because it is stable, and it keeps, it is higher than a normal natural, office environment or something, where the timber remains for its life a lot more drier, but it doesn't reach that point in which we need to worry, too much about mold occurring and things like that.
Yeah, great. And Tyce, how long are these Glulam beams? And how does that sit within the world, compared to other projects, and what kind of challenges are proposed with this size of beam?
They're very long, to say the least, I suppose. The longest one we've got on the project, because of the shape of the aquatic centre, it sort of stays fairly consistent, but then at the end it sort of tapers out to an extra few meters. So the longest beam in the project is 42 meters, which is it's actually, we believe it's the longest Glulam beam that we've ever produced, but it's certainly the longest beam that's ever come into the country as a single beam. So the project will have the longest timber beam as a single piece. So there is larger beams in the country, but they're all made of smaller Glulam beams that are spliced together with large steel plates or steel block connections. So there were a lot of challenges. Originally, the design was a spliced beam, so multiple, 3 or 4 segments with a big steel connection. But obviously, as Ben touched on before, that does lead to corrosion issues with the steel blocks and how you treat that. So when we came on board, we offered a couple of solutions for achieving the full span in one piece. We have a limitless system, which is a proprietary system we developed in-house, and that's like a full depth finger joint with a scarf joint at the bottom. And we glue that and clamp it in a very precise way, but that has to be done on site. So we would normally send our people out accompanying the beams, and then we would assemble them into the full length. And that is a pure timber to timber connection. There's no steel in that connection. However, obviously, and that was the preference for the project originally, but obviously with COVID, we had no guarantee we could actually get our people here to do that gluing and clamping, and there is no expertise locally to do that. So that was when the decision was made that we would proceed with full length beams and ship them in a special transport known as break bulk or ro-ro, which is roll and roll off vessels. So the beams are, as I said, there's 13 of them that are the full length, and then the 2 at the ends are spliced, which are sort of sitting on the steel column, so they don't actually span that full length. They sit on other structures. But the ones that do span full length are a full length beam, and we are transporting them on a roll on roll off vessel on a series of what's called boogies, which are like if you've ever seen those prime movers with that separate dolly wheel at the back, it's essentially a simplified version of them. We use a pair of them and we load the beams onto those dollies or boogies, and then they roll into the hull of the ship. Then they ship them in the protection of the internal hull, so they're not exposed to the atmosphere or the weather during sea freight. And then when they get to Melbourne, they're rolled off, and then they go on a prime mover with a separate dolly and head out to site as that full length. So, but it is quite a challenge, because you've got to deal with not only the the complications of getting it in the ship that way, but you've also got to deal with road freight, both in Germany and Austria and into Belgium, where we're shipping them out of in the port, and then obviously when they come into Melbourne and go out to Mount Gambier, which is quite a long distance. So, putting permits in place and getting truck diagrams and that set up and agreed is quite a process. But we've done that luckily a few times. Certainly some very large beams in Singapore we did a couple of years ago, and it's good because it's now it's allowed us to offer that long beams to Australia, which is not what we've done that before. So
absolutely, it's probably one of those things where COVID challenges, but you actually can take some learnings out and a new way of doing things. So what are you trucking them in very early morning, or how do you get that permit to actually drive something and transport something that's so long?
Yeah, well, the problem with those problem with long and oversized loads like that is that you generally can't, depending on the actual, the council that you're driving through or the state you're driving through, both in Australia and in Germany, is that they have different restrictions. So sometimes, you need to have pilot vehicles and police escorts. Sometimes you don't, depending on where you are and what highway you're on and everything. But generally speaking, all these loads will be piloted, most likely as well with a police escort. They need to be flagged and with flashing lights on them. I know that in Victoria, you can't travel during the night because they're such large beams. They need to travel during daylight hours so you can see them. But then there's also restrictions about peak times, so you have to be very precise. And it doesn't just take a 7-hour, 8-hour trip out to Mount Gambier. It takes days to get there because you are moving slow and it's a process. So. And those permits are generally handled by the freight, the freight contractor, which is good because they're obviously the experts in it. So, in both cases of Australia and Germany, we've partnered with freight contractors to handle all that for us.
So we got one dimension's 42 meters long. What are the other dimensions? And do you know what the limiting design criteria were? Because it's obviously not a standard glulam, or maybe it is a bit of a standard glulam beam, just scaled up design that people are familiar with. But what were the design criteria? Yeah,
I mean, that's true. It is just a glulam beam. It's 240 by 1440 mil deep, which is it's a very large chunk of timber. But it's designed in the same way, and the limiting criteria is deflection as it normally is with most timber structures, especially long span like this. We've also got a Curto panel roof, which is an LVL panel, which is spanning from rafter to rafter to form the actual solid roof above that. Limiting criteria would be deflection and.
And you're exposing the roof as well there, Ben, I think, are you, from the renders I saw?
So as Tyson just touched on, the original design had a timber purlin system with ply, and then we did our condensation analysis with our facade engineers to make sure that we got the moisture, obviously, from a moist environment, and where condensation forms. Being in Mount Gambier, it gets quite cold, so we were quite controlled and had a lot of studies done to make sure that we were controlling where condensation formed. And then when the contractor was on board, it got offered to do through Hess the CLT LVL panel. So we kind of changed the entire design of the system with Hess and their engineering team and the contractor, and had multiple workshops there, and arrived, and it helps them with their buildability as well. Saves them, they get provided a safe work platform they can build straight on top of. So we've got our rafters and then the LVL panel, and then we've got a second roof build up on top of that with our insulation, our condensation control, our air movement, and then metal sheet.
And lifting the beams and installation, can we speak a little bit about that? And is there anything not so standard about doing that with beams so long?
Yes and no. I mean, obviously the length means that you need to use a spreader, spreader bars and things like that to lift with it. But we're installing dedicated lifting points, so there's steel angles that are fixed to all four corners at the two locations we're lifting from. But generally speaking, we've designed and checked that the capacity of the beams is suitable during that temporary lifting process. And in this case, we're lifting from points that are 12 meters apart. So there's quite a substantial cantilever. Normally you would lift it, say, quarter points along the length of a beam because it's equally shared sort of cantilever to the backspan. But in this case, we have a 12 meter center between the lifting points, and then the cantilever is another 12 or 13 meters out from the end of that. So the beams are all generally, when I touched before about the largest one, but the majority of them are 37 to 38 meters long, and they're lifted in the same way, though, 12 meter centers and then cantilever the rest. Fantastic.
And looking forward now, as we're approaching the end of the podcast, is there anything you'd like to leave us with, or any lessons learned you've got from this to take on to future projects? Might start with Ben, if you.
Sure. We've learned the entire way through the process, from the initial feasibility study where we were researching, different geometries and different ways to form up the structural solution. Of course, being able to use local timber as well was important for us during the design phase, so that when it got tendered, it was competitive for both the local industry and the international industry. So we had contact, and the design team and the engineers had contact with both local timber suppliers as well as international timber suppliers. And the design we arrived at to tender enabled that competitive market to happen and provide an opportunity for Australian suppliers to be able to tender on the project. And then, through the tender process, and once Hess were engaged by their head contractor, we then started refining through workshops with the contractor, was very involved, the structural steel, and with the Hess engineering team, to make sure that we had one system that actually works together, because we've got different movements between timber and steel, and they've all got to connect together, and they've got to transfer loads. So there was a lot of workshops, a lot of research, and right through to, while we're still there in manufacture now, we're still having this dialogue that's been ongoing through 3 or 4 or 5 different parties to make sure we get everything. We're learning things that the standard washer size that meets Australian standard is not what they provide in Germany. So there's these little differences as well that you don't normally think is going to be an issue. So there's been many points along the journey where we've learned something, and hopefully by this process, and Tyson and his team getting these beams in, and the contractor getting their local people as well to work with the timber once it's on site, that there's a lot of upskilling to the region, and it can really showcase what timber can do. So it should be really good for both the Australian timber industry, the local industry down there, and also for each one of the professionals involved. We've all taken away this knowledge base, which we don't normally get exposed to or get the opportunity to learn.
Yeah, brilliant. And for you, Tyson?
Yeah, so it's certainly a learning experience for us as well. This is the first aquatics that we've done in Australia, and certainly the longest beams we've ever brought into Australia. So there were a lot of new challenges to face that we haven't faced before, and so we've gone through that similar education process, not to the same extent, but in a different way we have. And even now, we're lucky because the project, it was a challenge to design it, but it was enjoyable because this is it's a unique structure. It's not just the bread and butter stuff we do every day, and this is the stuff we work for, we live for. This is our passion. So getting large span structures like this, is fantastic, and certainly good for the Australian timber industry, because we're seeing now more and more of these aquatic centres and basketball stadiums, netball courts, and long spanning pavilions and things that are coming in, and people obviously, they appreciate the look of timber and what it can provide to these sorts of buildings and structures. So, and even now, to the extent that the learnings we've achieved from this project, with long span and with bringing timbers in via this method and special transports, that we're now starting to offer these projects in a similar way, where we can come aboard and say, hey, this splicing a beam with a giant steel plate that might not look as what you want, but you're doing it as a compromise. We don't have to do that anymore. We can bring in these large beams, and we can do these, and then it doesn't just restrict you to local supply, which is always good, of course, local supply, but the capabilities sometimes aren't here, and we need to look in other places. So I think there's a bright future ahead for these long spanning structures, as well as the timber industry as a whole, which is obviously growing exponentially over the last few years. So
100%. And something just popped up into my mind, which might be useful, is like say office buildings, 9 meter spanning grids, but with robustness considerations, having the one piece of glulam spanning 18 meters, maybe applications like that, it could be really useful going forward.
Yeah, certainly. And it's certainly been looked at. 9 meter spans, 10 meter spans is not uncommon. And it's obviously, we see that a lot more because people want to get that car park size, support structure underneath. So it is a challenge sometimes, but we've got certain proprietary methods and ways that we do things with hybrid beams that can address the robustness, and a lot of that comes down to the design of the connections. But you're right. We could start now doing 18 meter or even more than that. We could span a beam, the full length of a building if we really wanted to. But,
So I was meaning with the double span. I didn't articulate it properly, like with the robustness. So you still the double span, have the mid span and all that. Because 18 meters with an office building is pretty big span.
Of course.
All right. Well, thanks so much for coming on the podcast, Ben and Tyson. It's been a real pleasure hearing about this project. I'm going to share some links in the show notes for both your organisations, but also for this project. Is there anything else you'd like to plug as for the listeners to go and check out?
Yeah, I'd just probably like to add that we're also covering this with a promotional video. So of the manufacturing, transport, logistics, and installation of these large beams. So, in the coming months, once we get the beams onto site and install them, we'll start to then publish this video, which will show everything, not just the transport, but especially how we moved them in Germany, how we manufactured them, and how they went in and out of the ship, getting out to site in Victoria, and the challenges that we faced there, and then watching them going on site and seeing the finished product. So keep an eye out for that.
Can't wait to see that, and we'll definitely share it on all the Wood Solutions social media and everything when we get a hold of that, because it really is an amazing, innovative project. So thanks, gents, and appreciate it.
Thanks, Adam.
No worries, thank you.